Hello, my name is Lily Sumrow. I'm a senior at the Hockaday School in Dallas, Texas, and today I wanted to talk to you about microbubbles. So, microbubbles are gaseous bubbles in liquid, and they can be coated with lipids or proteins or polymers, and they can be injected with different drugs or substances depending on the purpose for the bubbles, but the original purpose was for ultrasonic imaging. Microbubbles are about 10 millimeters wide, so they're really small and they're used to affect the density of the tissue. Since ultrasonic imaging relies on the density of the tissue, you can use the microbubbles to focus the image more. So this was the original intention of the microbubbles, but the application I want to talk to you about today is actually drug delivery. So whenever scientists use microbubbles to deliver drugs, they coat it with usually like polymers or some kind of like solid substance, and then they load the drug into the bubble. Like I said, microbubbles are about 10 micrometers wide, which is about the same size as a red blood cell. So this is really convenient because this means they can fit into capillaries or microvessels. But the coolest thing it can do is it can actually break into the blood-brain barrier. This is really useful because in the past, it's been really hard to access the central nervous system. So the ultrasonic waves make the microbubbles vibrate, and they break apart the cells of the blood-brain barrier, but they don't do too much damage. And then they can enter into the bloodstream in the brain, and then they break apart and they can release the drug locally. This dramatically decreases the negative side effects of chemotherapy or other drug delivery processes, and it can get the drug directly to the tumor. So that's a really cool feature of microbubbles, and it's a really unexpected use for that kind of technology. Thank you so much for listening to this mini lecture, and thank you so much for this opportunity.